drugs work? Well, if that was an easy question to answer, there would really be no need for these videos. That said, there is an underlying principle that holds true for most drugs known as the drug-receptor paradigm, or drug-receptor interactions. Let's say you take a medication. One of the most common ways people take medications is PO, meaning orally or by mouth. So you take your pill, you swallow it, and it goes somewhere in your body. Eventually, the active ingredient is released. This is the actual drug. Now, you may hear a few other names to describe a drug depending on the context. Words like substrate, ligand, agonist, and antagonist are a few of the more common references. But where is this drug going? Well, the drug's target is in most cases a protein that might be in or on a cell, a tissue, or a membrane. Ultimately, the drug's target is its receptor, hence the drug-receptor paradigm. When the drug binds to its receptor, there are a series of downstream events, kind of like a biological assembly line, that eventually lead to a response. Now, I know that doesn't answer a whole lot about how a drug works, but understanding this simple concept is foundational to understanding pharmacology. You see, there are so many drugs which can make the study of pharmacology seem very intimidating. Despite this, it turns out that most of them leverage the functionality of a relatively small number of receptors. Now, I won't lie to you, that doesn't mean that things don't get pretty complex. But understanding how each receptor works will allow us to understand why certain medications work, eliminating a lot of the memorization, allowing us to rationalize instead of regurgitate, and even predict the actions of drugs that we have never seen before. Because proteins play such a big role in the drug-receptor paradigm, in this section we will briefly cover protein structure before moving on to the 6 major types of drug receptors. These include transmembrane ion channels, transmembrane G-protein coupled receptors, or GPCRs, transmembrane receptors with linked enzymatic domains, intracellular receptors, including enzymes, signal transduction molecules, transcription factors, structural proteins, and nucleic acids, extracellular targets, and finally, cell surface adhesion receptors. Look at that. That's only 6 things. Pharmacology is already looking more manageable. And don't worry, we will take them one at a time. If you enjoyed this content, please like and subscribe. Stay curious, and I'll see you in the next video.